So today we will spend a bit more time talking about how to convert between micro, the chemistry world of atoms and molecules and tiny things that we can't see with our eyes, observe with our eyes, into the macro world, grams and things that we can hold in our hand. So in order to do that, we need to go back and define atomic mass. What is atomic mass? Atomic mass is the mass of a single atom in the units of AMU, atomic mass units. So if you remember, the last thing we talked about was writing elements like this, where this number up top is known as the mass number. That's the atomic mass number. Remember, we said that number is composed of protons plus neutrons. So carbon is element number 6. So carbon has 6 protons and carbon-12 has 6 neutrons. So the atomic mass is the sum of protons and neutrons. You remember that? So one carbon atom weighs 12 atomic mass units because it's got 6 and 6 protons and neutrons. It weighs 12 atomic mass units. This is a tiny, tiny scale, atomic mass units. It's the weight of one single atom of whatever you're talking about. Hydrogen 1 atom, it weighs 1 AMU. An oxygen 16, it weighs 16 AMU. A carbon 13, that's another isotope of carbon, remember? That weighs 13 AMU. Okay, so this is micro. This is atomic mass units. It's micro scale. How do we get into the macro kind of scale? Well, what if I measure out a quantity that I can physically see, like 12 grams of carbon, but specifying it's 12 grams of carbon-12 atoms. So weigh out 12 grams. It takes not just a little bit, but a lot of atoms in order to balance the scale here and measure out 12 grams. In fact, it takes 6.022 times 10 to the 23rd carbon-12 atoms in order to measure out 12 grams of carbon atoms. It requires 6.022 times 10 to the 23rd, positive 23. That is a giant number, really large number. So this is a really large number that we will become very familiar with. It's so familiar that we use this definition to say, instead of writing this giant number all the time, let's make this relationship that 6.022 times 10 to the 23rd really is representative of 1 mole. 1 mole of anything is 6.022 times 10 to the 23rd of those things. The person that discovered that it took 6.022 times 10 to the 23rd of those things is named Avogadro. So you might hear that called Avogadro's number. How much does half a mole? Well, if 1 mole weighs 12 grams on the macroscopic scale, then half a mole weighs half of that, so 6 grams. Yeah? You see all those decimals after the end? Remember, those are sig figs. We know the weight of carbon-12 to that many sig figs, so we could actually confidently say that half of that is 6 grams with that many sig figs also. Okay, so mole is confusing to a lot of students in the very beginning. It's just the name for a number. Just like a dozen means 12, a pair means 2, it's just the name of a number. A mole means 6.022 times 10 to the 23rd. So if we asked, how much does 1 mole of something weigh, we can talk about the mole of eggs. How much does 1 mole of eggs weigh? That's called the molar mass of eggs. How much does 1 mole of shoes weigh? That's the molar mass of shoes. I know it's a bit silly. How much does 1 mole of atoms weigh? That's the molar mass of the atoms. How much does 1 mole of carbon-12 weigh? 12 grams. How much does 1 mole of marbles weigh? Anything. How much does 1 mole weigh in grams? That's the molar mass, and we will use molar mass a lot, a lot, a lot. How much does 1 mole of gold weigh? Well, the way we find that out is we look on the periodic table. That periodic table number is convenient because it tells us 2 things. It tells us 1 single gold atom, if it's a gold 197 isotope, 1 single gold atom weighs 197 AMU. But 6.022 times 10 to the 23rd gold atoms, also known as 1 mole of gold atoms, weighs 197 grams. That number at the bottom can be used in two different ways. It can be used on the microscopic scale, and the unit on microscopic scale is AMU. It can be used on the macroscopic scale, and the unit on the macroscopic scale is grams. Yep. I said that. Yep. Gram molecular weight is what you'll see it called sometimes. I am much more likely to call it a molar mass. But gram molecular weight, molar mass, the units can be AMU if you're talking about microscopic, one atom, or grams per mole if you're talking about a whole bunch of them. A mole explicitly. So what else can we do with this molar mass stuff? We can answer questions like, how many atoms are in 0.551 grams of potassium? There's our 0.551 grams. How many atoms of potassium are in it? We're going to find conversion factors and do a unit conversion thing with these guys. So how much does 1 mole of potassium weigh? We look on the bottom of the periodic table and we find 1 mole of potassium weighs 39.10 grams. Okay, how many atoms are in 1 mole of potassium? That number is not unique to the element. 1 mole always means 6.022 times 10 to the 23rd of whatever. This time it's 6.022 times 10 to the 23rd atoms of potassium. So the way we do our conversion is start with the lonely number, just like we did before. 0.551 grams of potassium is our lonely number. Multiply that by 1 mole. I realize I'm running on top of the stuff, but I didn't plan ahead. I'll do better. 1 mole of potassium weighs 39.10 grams. So my grams cancel. And 1 mole of potassium has 6.022 times 10 to the 23rd atoms of potassium. So when I do that dimensional analysis, that factor label method, writing out all my units, grams cancels, moles cancel, and I end up with atoms of potassium, which is exactly what we asked for. You should plug that in and make sure that you get the same answer as me, which is 8.46 times 10 to the 21st atoms of potassium. That's a lot of atoms. Anytime you have a quantity you can see, you expect to have a very large number of atoms. Don't forget that. Okay, that was atoms. What about compounds like this? How many grams are in 1 mole of Na2O? That's sodium oxide, remember? How many grams are in 1 mole of sodium oxide? This is a compound. It's still that there are 6.022 times 10 to the 23rd Na2O compound. Na2O formula units is the way I decided to write it here. So sodium oxide is composed of sodium and oxygen. We need to sum up the mass of these. Sodium on the periodic table is a mass of 23 grams per mole. And oxygen on the periodic table is a mass of 16 grams per mole. So we take our sodium mass from the periodic table, multiply it by 2 because every sodium oxide contributes 2 sodiums to the mix. And we add in our mass of oxygen, and we get a sum total of 62 grams per mole. 1 mole of sodium oxide weighs 62 grams per mole. Remember to multiply the sodium by 2 because every mole of sodium oxide has 2 of these and 1 of those. 2 sodiums, 1 oxygen. Okay, we didn't need to convert to a giant, a giant number here because they're asking how many grams. Grams is the quantity you see. When you're going to atoms or molecules, that should be a giant number, giant Avogadro's number style number because it takes so many of them. Okay, maybe that makes sense. I don't know. How many hydrogen atoms are in 72.5 grams? Should we get a giant number or just a normal number? A giant number because we're talking about atoms here. We're going to get a giant number. And if you didn't get a giant number, you did something wrong. So we're talking about a compound here, a molecule, C3H8O. We probably need to know the molar mass of this guy. That means how much does 1 mole of this stuff weigh in grams? So in pictorial form, we've got 72.5 grams we've got some molecules over here. These are my molecules, but really I'm asking about hydrogen atoms in this amount of stuff. So conversion factors are what we need. Molar mass is going to be one of those conversion factors. So I've got carbon. Carbon weighs 12 AMU, or 1 mole of carbon weighs 12 grams. So multiply that by 3 because there are 3 in this molecule. Hydrogen weighs 1 AMU, or 1 mole of hydrogen weighs 1 gram. So 1 gram times 8 hydrogens total. 1 oxygen times 16 grams total. The whole mass of this molecule is 60 grams. 1 mole of these molecules weighs 60 grams. Okay. One of these molecules has 8 hydrogen atoms. Remember, we're trying to find hydrogen atoms. And one more conversion factor we need to make sure we remember. 1 mole of these, 1 mole of anything is this many atoms. So how do we string together this whole conversion? So if we start with 72.5 grams, that's the lonely number. That's grams of this whole thing. And remember, we need to keep track of this thing because we're not eventually going to be in atoms of this thing. We want atoms of hydrogen and only hydrogen. So grams of that thing, we know that 60 grams is what that thing weighs when you have 1 mole of it. And 1 mole of this thing contains 8 moles of hydrogen. Yeah, 1 mole of this is 8 moles of that. 1 molecule contains 8 atoms of hydrogen. 1 mole of C3H8O contains 8 moles of H atoms, 8 moles of hydrogen. And then finally our Avogadro number, 1 mole of hydrogen is 6.022 times 10 to the 23rd atoms of hydrogen. We're going from macroscopic things we can measure to microscopic should give us a giant number. You should plug that in your calculator and make sure I did my math right. I came up with 5.82 times 10 to the 24th atoms of hydrogen in 72.5 grams of C3H8O. So all of that conversion stuff that we did before all leads us into how do we get from atoms to mass that we can see? That's where we're going with all that stuff. Not all that ocean water, barrels of salt kind of stuff. That's how it relates to chemistry. All right, that's good enough for now.